Okay, Algebra I Skills number 19, solving systems of equations, this time with graphs or tables. Okay, system equations, again, it's two or more equations that have the same variables, and there's different ways of solving them. We're looking for the ordered pair that makes both equations or all the equations true at the same time. So when we want to graph each equation. The intersection point is the solution. We'll explain why when we see an example. If the lines are parallel, then they don't have an intersection point. Therefore, they have no solution. And if the lines coincide, they're infinite solutions. So any point on the line works for both equations at the same time. Okay, so looking at an example, what's the solution to this system? Now, these are set up in slope-intercept form, and it's assumed that you know how to graph these lines. So we're not going to explore that in this video. We're instead just going to go ahead and graph them and focus on the solution. So the blue line is actually the bottom one. We didn't color code from here to here, but the blue line is the bottom one. Okay, so all the order pairs on the blue line make the bottom equation true. The red is the top equation, so everything on the red line makes the top equation true. So you remember the solution to a system is what makes both true at the same time. Well, what makes both true at the same time is this one point right here where they intersect, which is the point 1, 1. So you simply look at where they cross and identify that coordinate. That's the solution to the system. A second example, notice these have the same slope, so therefore they are going to be parallel, and there's no position. There's nowhere is it blue and red at the same time, so there's no solution for parallel lines. A third example, these are set up we've got one in slope-intercept form, one is set up in standard form, but when you graph them, it's actually the same line twice. Okay, it's exactly the same line. Therefore, any point that's on this line works for both equations at the same time, so there are going to be infinite solutions for this particular situation. Now, we also do have tables. So let's look at a situation where we're not given the graphs, but instead we're just given two tables. So here are 5 ordered pairs, 5 solutions to this equation, and here are 5 solutions to this equation. Remember, we're looking for the ordered pair that makes them both true at the same time. So you just explore the table, and you'll see that 2, 3 makes both equations true at the same time. To be a solution to the system means you must work for both. So 2, 3 would be your solution there.